Good morning, dear students. So let us study the next phenomenon of light, which is known as refraction of light. And I hope you have already gone through the syllabus of term 1 and term 2. Especially in physics, we have total 4 units. Okay. So this is the first unit called natural phenomena. In this, we are going to study. We are having 2 chapters. One is light, reflection and refraction. Another one is human eye and color. So these 2 chapters are merged with this unit called natural phenomena. So for this term 1 examination, you are having 2 chapters, that is 1 unit from the physics portion. So today we are going to study the refraction of light phenomena. Already we have studied about reflection of light in that spherical mirrors and laws and so many numerical problems we have solved in our last classes. So let us study what is the refraction of light phenomena. Okay, as we know, reflection of light is nothing but what? The bouncing back of light rays into the same medium. So in that case, we have used opaque objects. But here, to study the refraction of light phenomena, we need a transparent objects. Transparent, which exhibits the transparent medium characteristics. What do you mean by transparent medium? The medium, okay, or the objects which exhibits the transparent medium characteristics that allows the light rays to pass through it completely through it. So these are called transparent objects. So here, refraction of light phenomena. What is refraction of light? So here I will write the definition first. The bending of light rays, the bending of light rays when it travels from one medium to another medium. Okay. The bending of light ray occurs when the light rays travels from one medium to another medium. So here, in this refraction of light phenomena, we are considering 2 mediums. Both the mediums should be a different mediums. Okay. One medium to another medium. We are considering 2 different mediums to study the refraction of light phenomena. So here, the bending of light ray when it travels from one medium to another medium. For example, you can use air medium and glass medium, or air medium and water medium, or air medium and kerosene medium. That is left to us. We need to consider any 2 different mediums to study whether the light ray will refract from that mediums or not. Here I will draw one diagram so that we can understand the concept easily. Let us consider 2 mediums. One as air medium, another one as glass medium. So here I will use one glass material. Okay, glass material. Why we need to use here glass only? Because glass is also one transparent medium through which the light rays can easily pass through it. So here I am using one glass slab. Name the vertices of this glass slab. I will call this as A, this point as B, C and D. What is this? This is a glass material. So here I will write okay, this is the glass slab. Okay, next. Around this glass slab, we are considering one more medium, that is air medium. So this glass material, this glass slab A, B, C, D is surrounded around it, that is air. So one more medium we are taking here, air medium. Is it clear? How many mediums we took? Two mediums, air medium and glass medium. So how the light ray will changes its direction when it travels from one medium to another medium. So that we will study briefly here. So use any source of light from which the light rays are entering into this glass slab. So the light rays. So call this ray of light as incident light ray. Is it clear? So this ray of light is coming from one source of light which we kept at some distance from this glass slab. So this is the incident light ray. At this point, the light ray is striking the glass slab. At this point, call this as A and this as B point. At point B, the light ray is striking the AB face of the glass slab. So this is the point of incidence. We know how to denote the point of incidence. Is it clear? So B is the point of incidence. AB ray is the incident light ray. So this arrow mark shows that in which direction the incident light ray is traveling. Next, at this point, when the light ray is traveling from one medium to another medium, the bending of light ray occurs. According to the definition of refraction of light phenomena, when it travels from one medium to another medium, the light ray bends in the second medium. Second medium is nothing but what? Here, glass is the second medium we need to consider. Because air is the first medium. Why air we have to consider it as a first medium? Because we kept a source of light here. The light ray is traveling from air medium to glass medium. So when light ray travels from air medium to glass medium, bending of light ray occurs. What do you mean by bending of light ray? You can see, you can observe the light ray is changing its direction of propagation in these two mediums. Okay, so this is known as bending of light ray. So this is observed as the light ray is bending when it travels from one medium to another medium. The direction of propagation of the light ray is changing in the second medium. Is it clear? What is changing in refraction of light phenomena with respect to air and glass medium? The light ray changes its direction of propagation in the second medium. Why it changes its direction of propagation? That I will explain now. Here. See, so this is the incident light ray and this is refracted light ray. We know that we have to draw the normal line which is perpendicular to the face of the glass slab where the refraction of light takes place. So draw the normal line which is perpendicular to what? Face of the glass slab. So AB is the, I will use the another letter to indicate the incident light ray, P and Q, because AB we are using here already. So here PQ is the incident light ray, point Q is the point of incidence. When light ray travels from air medium to glass medium, one medium to another medium, bending of light rays occurred. Bending of light rays occurred. That is nothing but what? In the second medium, in glass medium, the propagation of light is changing. The direction of propagation of the light ray is changing. Here, we know normal line is always perpendicular to face of the glass slab. The angle between incident light ray, here I will write incident ray of light, QR, Q to R. This ray of light is known as refracted. Refracted, okay? Refracted ray of light. So angle between normal line and incident ray of light is called angle of incidence. The angle between normal line and refracted ray of light is known as angle of refraction. In this case, In refraction of light phenomena also, we are using small angle I to denote it as an angle of incidence. Small angle r is called as angle of refraction. Same we have used in case of reflection of light also. But that is known as angle of reflection in case of reflection of light. But here in refraction, small r should be angle of refraction. Okay, here. So angle of incidence is lying between normal line and incident light ray. Angle of refraction is lying between refracted ray and normal light. Okay. So here you can see why the light ray bends when it travels from one medium to another medium. Because it depends on its speed. The speed of light is different when it travels from one medium to another medium. We know that the speed of light in air is 3 into 10 to the power 8 meter per second. Okay, we know already the light travels at this speed in air or vacuum. What is that? 3 into 10 to the power 8 meter per second. Is it clear? So this is the air medium. In which medium? Yes, I'm right. In which medium the speed of light is more, that medium is known as rarer medium. That is optically rarer medium. Why air medium is always considered as a rarer medium? Because in this medium the speed of light is more. Okay. Glass is considered as a denser medium. What is that? Glass medium is considered as a denser medium. Why glass medium is considered as a denser medium? Because here the speed of light is less as compared to speed of light in air medium. So that's why we used to call air medium as a rarer medium and glass as a denser medium. Okay. When the light travels from one medium to another medium, the speed of light also varies. It is different in both the mediums. So that's why bending of light ray occurs. That's why the light ray changes its direction of propagation in the second medium. How we can say that the light ray is changing its direction of propagation? Observe the diagram. Here, when light ray is traveling from air medium to glass medium, this refracted ray of light is bending towards the normal. Okay, towards the normal. When light ray travels from rarer medium to denser medium. How the refracted ray of light bends? That is towards the normal. In this case, angle of incidence is greater than angle of refraction because the gap between normal line and incident ray is more compared to the gap distance between refracted ray of light and normal light. So obviously angle of incidence is more than the angle of refraction. But the condition is that the ray of light must travel from air to glass medium. So you can say, now we can say that the conclusion is that why the direction of propagation of the light ray changes when it travels from rarer medium to denser medium. Because the speed of light is varying when it travels from one medium to another medium. So that's why here the refracted ray of light is bending towards the normal. Is it clear? In this case, angle of incidence is greater than the angle of refraction. Obviously, angle of incidence is not equals to angle of refraction. Is it clear? Next, moving to the another diagram. That also explains how the refraction of light ray takes place. One more glass slab we will use here. Glass slab. Or else you can take water also in this glass container. If you are using any type of container, you can fill that container with the water. So that we are considering two mediums, one as air, another one as water medium. So again I will consider here glass only, so that we can compare the things, what are similar and what are the different points. A, B, C, D, and this is glass slab. Okay, again the incident ray of light is traveling from glass medium, and this is air. Again this is air medium, because this glass slab is surrounded around it with the air. Here the incident light ray is traveling from glass medium to air medium, that is from denser to this is denser in medium, okay, because the speed of light is less in glass medium. Next, this is air medium, A, B, C, and D. This glass slab is surrounded with the air medium around it. Air medium is rarer. Optically it is rarer. Okay. When light ray travels from denser medium to rarer medium, what happens? Here we have studied when light ray travels from rarer medium to denser medium. What happened? We have observed with this diagram, with the help of this diagram. Now we will study when the light ray travels from denser to rarer medium, how the light ray bends. So this is the incident light ray, point of incidence. PQ is the incident light ray. At this point we need to draw the normal line which is perpendicular to face, CD face of the glass slab. But here what happens, when light ray travels from denser medium to rarer medium, the refracted ray of light will bend away from the normal line. This is the normal line. Okay, N dash. N dash. Okay. When light ray travels from denser to rarer medium, refracted ray. This is the refracted ray bends away from the normal line. Away. So here the distance. Now we have to consider this as an angle of incidence only. This as angle of refraction. When refracted ray is bending away from the normal, obviously angle of incidence is lesser than the angle of refraction, because the distance between normal line, refracted ray is more compared to distance between incident ray of light and normal line. Okay. The same diagram I will draw here itself only. So consider again one more point of incidence here. The light ray comes out from this glass slab. Yes or no? Because this is the transparent medium. Glass is transparent in nature. It allows the light beam to pass through it completely. So obviously this QR ray of light will also come out from this glass slab through this CD face. So here draw one more normal line at this R point of incidence. Here we have to consider R as the point of incidence, because QR ray of light is striking the CD face of the glass slab. Normal line, okay, which is perpendicular to CD face of the glass slab. When QR ray of light, QR refracted ray comes out from this glass slab, that is traveling from denser to rarer medium. Yes or no? Denser to rarer medium. So this ray of light will also bend away from the normal line. Is it clear? Incident ray of light, PQ. QR is the refracted ray of light. We can call RS as emergent ray of light, which is coming out from the glass slab A, B, C, D. Is it clear? If if we are drawing a particular separate diagram for the ray of light when it travels from denser to rarer medium, we can call this QR as refracted ray. If we are indicating, if we are denoting all the rays of light, that is incident, refracted and emergent ray of light, we can call RS as the emergent ray of light. And this E is nothing but what? Angle of emergence. E is what? Angle of emergence, which is lying between normal line and emergent ray of light. Is it clear? How many angles are there here? Angle of incidence, angle of refraction, angle of emergence. How many mediums are there in this diagram? Two mediums. Rarer medium, that is air. Denser medium, that is glass medium. Is it clear? How many normal lines we have drawn in this diagram? Two. N dash. One more is to the CD face of the glass slab. How many rays of light we have taken here? Three. Incident, refracted and emergent ray of light. So this is about the refraction of light phenomena. We can explain with the help of diagram thoroughly. I hope you understood, my dear students. The next I will explain the laws. What are the laws of refraction of light? Okay. Laws of refraction of light. First law, that is incident light ray, refracted light ray and normal light. Incident ray of light, refracted ray of light, normal light at the point of incidence with interference of two mediums. We need to add this additional word in the first law of refraction of light. Everything is same as in case of we have studied in reflection of light, first law. Incident light ray, refracted light ray, normal line at the point of incidence with interference of two mediums, rarer medium and denser medium. All lie in the same medium. What are those? Incident ray, refracted ray of light and normal line, all lie in the same plane with the interference of two mediums. Second law is very important. So using this one, we are solving number of numericals. Okay. The second law of refraction of light is also known as Snell's law. What is that? Snell's law. Okay. What is the another name of a second law of refraction of light? Snell's law. What it states? Sin I by sin R is equals to constant. How to define the second law of refraction of light? The ratio of sine of angle of incidence. Ratio is nothing but what? We are indicating this fraction using numerator and denominator. The ratio of a sine of angle of incidence to the sine of angle of refraction is equals to constant. Okay, what is that? I repeat, the ratio of sine of an angle of incidence to the sine of angle of refraction is always constant. Constant is nothing but we are getting here numerical values only. That means in numbers. Okay. We are getting some integers or in the form of numbers only. Is it clear? Sin I by sin R is equals to constant. Constant is nothing but only numerical values. So this second law of refraction of light is also known as Snell's law. So we are using one trigonometric function, that is sine. Remember this trigonometric function, sine. We are using sine trigonometric function in Snell's law the concept of refraction of light phenomenon. How to use this law to solve the numerical problems that we will study in the next class. In refraction of light, we have to study, okay, this is the next thing, how the light ray will refract through spherical lens. Okay, as we studied the reflection of light through spherical mirrors. In refraction of light, we are using a spherical lens because lens is transparent in medium, which has the capability to allow the light rays to pass through it completely. Is it clear? So spherical lens are of two types. One is concave lens, another one is convex lens. So these two are derived under spherical lens. So using these two spherical lens, we will study the refraction of light phenomena, how the light ray will travel through concave lens and convex lens, and its ray diagrams and its characteristics nature. Okay, we will study in these two concepts in our next class. Thank you.